Hi there, and welcome back to another Papetti Math YouTube video tutorial, where I'm going to be teaching you, yes you, Algebra 1. And in this lesson, we're going to finally begin exponential functions, the name of the chapter. So this must be a big lesson. So starting with exercise number 1, we're going to work through each of these exercises and really get an idea of what exponential functions are. It says in the top introduction paragraph that so far you have covered linear functions. You should recall that linear functions, y equals mx plus b, are functions that have a slope, or rate of change, that remains constant throughout the entire function, which means the rate of change is always the same throughout a linear function. Exponential functions have a noticeable difference that we're going to explore right now. So in exercise number 1, it says a radio station calls Jananda to inform him that he won a contest and offers him 2 options to choose from. Option 1 is $1 million. Option 2 is a penny today, 1 cent today, and each day after for the next 30 days, they're going to double the prize amount from the previous day. So decide which option is going to give you the most amount of money. How did you arrive at that conclusion? You might want to use the table of values to help you with your decision. Okay? So pause the video and try that out right now before we get into it together. Okay, now that you've had a couple seconds or minutes, however long you took, to attempt that problem right there to figure out whether you want option 1 or option 2, let's see which one will yield the most amount of money. So option 1 is $1 million, given, done, boom. All we need to do is look at option 2. Now it says on every 30 days, each day after for the next 30 days, they will double the prize amount. So on day 0, they're going to give you 1 penny. Okay, so that means after 1 day, they're going to give you 2 cents. After 2 days, they'll give you 4 cents. After 3 days, they'll give you 8 cents because we're doubling the prize amount every day. After 4 days, we're up to 16 cents. 5 days, we're up to 32 cents. 6 days, we're at 64 cents. Okay, so these numbers right here are making me lean towards option 1 because I know we're going to 30 days, but still, look, we're less than $1. We're not even making $1 yet on a single day. And $1 million is looking a lot more enticing. But let's keep going and let's see what happens. 7, we're now at over $1 at $1.28. 8 days, we're at $2.56. 9 days, $5.12. 10 days is $10.24. 11 days will give us $20.48. 12 days will give us $40.96. Okay, so we're still only at $40, and we're trying to get to $1 million right now. I don't know if we're going to get there because we're at 12 days. We're almost halfway there. We're only at $40.96. So we go to 13 days and we're at $81.92. 14 days and we're at $163.84. And 15 days will give us $327.68. So again, 15 days, halfway there, we're only at a couple $100 instead of $1 million. We have to get through the thousands and then to $1 million. I don't know if that's going to happen, but let's keep looking. 16 days, we'll have $655.36. After 17 days, we're going to have $1,310.72. 18 days, we're going to have $2,621.44. 19 days, $5,242.88. 20 days, 2/3 of the way there, and we're at $10,485.76. So even 2/3 of the way there, we're only at $10,000. We're going to make $990,000 more choosing option 1. But we're not there yet. So 21 days, we're at $20,971.52. 22 days, we're going to have $41,943.04. 23 days, we're at $83,886.08. 24 days, almost at the end of our time period of payment. We're still not at the million, 167,772.16 cents. I'm going to move my video up over here. Okay, 25 days, we're going to have 335,544.32 cents. We only have 5 days left, and we still haven't reached a million yet. $671,088.64. For the 27th day, we'll have, wow, here we go. Now we'll have $1,342,177.28. After the 28th day, we're going to have $2,684,354.56. The 29th day, we're going to have $5,368,709.12. And finally, after 30 days, they're going to give us $10,737,418.20 plus all the amounts before this, which is going to be a lot more than just $1 million. So although option 2 starts off small at 1 penny, option 2 is going to be an example of an exponential function because the prize money is increasing by a common ratio or a growth factor. And exponential functions grow a lot faster than a linear function, which is just a set amount over and over. This rate of change in the beginning was going up by a penny. Now it's going up by $5 million. That's a lot of pennies. So we could use a general form of an exponential function to represent this information. Y equals a times b to the x. So a times b to the x, it says, is just as you have learned y equals mx plus b is the general form of a linear function. You will now be working with exponential functions that have a general form of y equals a times b to the x, where a represents the y-intercept and b represents the growth or decay factor. So using all of this information above, our y-intercept is where x is 0. So our y-intercept is going to be a penny. So for this problem up here, we had 0.01 as our a value, and our b value is our growth factor. What are we growing by every time? And exponential functions, we're looking for a constant factor, what we're multiplying by every time. And that's going to be times 2, times 2, times 2, times 2, times 2. So our growth factor is 2. So an equation that represents every possible value here is y equals 0.01 times 2 to the x. So if we just do y equals 0.01 times 2 to the 30th power, we're actually going to get this number right here, and you could try that right now. So that's a shortcut way of not having to write out this entire table of 30 days. We could just use a formula that looks like this to find out $10,737,418 is the better option than option 1, which is just $1 million. Ha, just $1 million. So if this video is helpful in helping you see what an exponential function is, give it a thumbs up, and you're ready for exercise number 2 now on exponential functions. Thank you for watching.